You have a Kubernetes app, a deployment, a service, an ingress, a config map, a secret, and HBA. 6 YAML files. Now ship it to dev, staging, and production, where the image tag differs, the replica count differs, the domain differs, and production has resource limits the others do not. Suddenly you have 18 files, most of them copies of each other, and someone has already fixed a bug in the staging copy and forgotten the production one. That is the problem Helm exists to solve, and it solves it well. It also has a genuinely questionable design at its core, which almost nobody tells you about, and which you will absolutely hit in your first week. So we will cover both. 9 concepts, 1 running example, an API with a Postgres database and an ingress deployed to 3 environments. This assumes you know Kubernetes. If you do not, watch that episode first. Look at what actually happens without Helm. You have your 6 YAML files for dev. You need staging, so you copy the folder and change a few values. You need production, so you copy it again. Now every change has to be made 3 times, and it will not be. Someone bumps the image tag in dev and staging, forgets production, and production silently runs last week's build. That is not a hypothetical. That is a Tuesday. And it gets worse when you want to install somebody else's software. You want posters in your cluster. That is not one YAML file. It is a stateful set, a service, a headless service, a config map, a secret, a pod disruption budget, an Rollback role. Are you going to write all of that from a blog post and maintain it? So there are really 2 problems here. 1, parameterize my own YAML so I do not copy it per environment. 2, install and upgrade somebody else's stack as a single unit. Helm is the package manager that answers both. Think apt or npm or maven, but for Kubernetes. Concept 1. The chart, a package of templated Kubernetes YAML. A Helm chart is, physically, a directory with a specific shape. Chart.yaml is the metadata, the chart's name, its version, and the app version it deploys. Note that those last 2 are different things and people conflate them constantly. The chart version is the version of your packaging. The app version is the version of the software inside. Bump the chart version when you change the templates. Bump the app version when you ship new code. This file is your chart's public API, and you should treat it that way. The templates directory holds your Kubernetes YAML, but with placeholders in it, and the charts directory holds other charts that yours depends on. That is the whole structure. Package that directory up and you get a versioned, shareable artifact you can push to a registry, and anyone can install your entire application with 1 command. Concept 2. How the parameterization actually works. Here is the core mechanic. In your templates directory, you write normal Kubernetes YAML, but wherever something varies, you punch a hole in it. When Helm renders that template, it looks up replica count in your values and substitutes it. Where does the value come from? A chain, and precedence matters. Bottom of the chain, the defaults in values.yaml. And at the top, a command line -- set, which beats everything. So 1 chart, 3 tiny values files, 3 environments. Dev overrides replicas to 1. Production overrides replicas to 10. Sets resource limits and points at the real domain. The templates themselves never change. And that is the whole promise of Helm delivered. 1 source of truth, many deployments. There is more syntax, if blocks, range loops, the .release object that gives you the release name and namespace. But this substitution is the idea, and everything else is decoration on it. Concept 3. The release, the concept that separates people who use Helm from people who understand it. This is the concept that unlocks Helm, and it is the one most tutorials skate past. A chart is a template. A release is one installed instance of that chart with a name. If you are a programmer, the chart is the class and the release is the object. So you can install the same chart twice into the same cluster with 2 different names and 2 different values sets. Helm install API dev and Helm install API prod, and they coexist happily because every resource name in a well-written chart is prefixed with the release name. Now the part that matters operationally. Where does Helm store the fact that a release exists, and what is in it? Not on your laptop. It stores it in the cluster, in a Kubernetes secret in the release's namespace. That has 3 real consequences. 1. Helm is not the source of truth, your cluster is. So any teammate with kubectl access can run Helm list and see exactly what you installed. 2. If you delete that secret, Helm forgets the release exists, even though the resources are still running, which is a genuinely confusing situation to be in. 3. This is why Helm 3 has no tiller. Helm 2 ran a privileged server-side component called tiller that was a notorious security problem. Helm 3 killed it and just uses your kubectl and a secret. If an interviewer asks what changed in Helm 3, that is the answer. Concept 4. The feature that actually justifies Helm. When you run Helm upgrade, Helm does not just apply the new YAML. It saves a new revision, revision 1, revision 2, revision 3. Each one a complete snapshot of the rendered manifests and the values that produced them. Run Helm history and you see every deployment of that app in order with a timestamp and a status. And because it kept those snapshots, Helm rollback is a single command that takes you back to any of them. Production is broken at 3 in the morning. You type Helm rollback API prod, and you are back on the last known good revision in seconds, without needing to know what changed, without a git bisect, without waking anyone. That is the feature that justifies the whole tool, and it is the answer to why Helm and not just kubectl apply. Because kubectl apply has no memory. 2 flags to know. -- atomic means, if this upgrade fails, automatically roll it back, so you never end up half deployed. And -- wait means, do not report success until the pods are actually ready and passing health checks. Use both. Without them, a broken upgrade will report success and leave you in a half-applied state, which is the worst place to be. Concept 5. Helpers. How you stop repeating yourself inside the chart. Your deployment, your service, and your ingress all need the same name and the same set of labels. Writing that expression out 3 times is exactly the copy-paste problem you adopted a Helm to escape, just one level down. So Helm gives you named templates, which live by convention in a file called _helpers.tpl. The underscore prefix matters. Files starting with an underscore are not rendered as Kubernetes resources. They just define reusable snippets. And then every template that needs a name just includes it. 2 things worth naming here. First, that 63-character truncation is not paranoia. It is a real limit, and long release names really do break charts, which is why every generated chart has that trunk 63 in it. Second, and as interviews like, but you've done in the bit, help it to, and you to the Kubernetes recommended levels. I thought Kubernetes managed by. Every tool in the ecosystem understands them. Concept 6. Dependencies, the superpower, and the trap that comes with it. Here is the superpower. In Chart.yaml you declare a dependency, name PostgreSQL, version 14, repository bitnami. You run Helm dependency update, and now installing your chart installs Postgres 2. An entire production-grade database with its stateful set and its secret and its pod disruption budget, all maintained by someone else as a single line of configuration. That is genuinely excellent. And you configure that subchart from your own values file by nesting its values under its name, a Postgres key in your values.yaml, containing whatever the Postgres chart's own values expect. Now the warnings, because there are 2 and they both cost people real time. First, a dependency is somebody else's code running in your cluster, and its values schema is theirs, not yours. When they release a new major chart version and rename a value, your deploy breaks in a way that has nothing to do with your app. Pin your dependency versions. Second, and say this in an interview, running your production database as a subchart of your application chart is usually a bad idea. It is superb for local development and for CI, where you want to throw away Postgres in one command. But in production, your database should almost certainly outlive your application's release. You do not want a Helm uninstall of your API to be one typo away from deleting your data. Separate the life cycles. Concept 7. Hooks, running things at the right moment in a release. Some things must happen at a specific point in a release. The classic, run your database migrations after the new code is deployed but before traffic reaches it. Or, depending on your strategy, before the new pods start at all. Helm's answer is hooks. Now Helm runs that job as a separate step during the upgrade, waits for it to succeed, and only then proceeds with the rest. If the migration fails, the upgrade stops, which is exactly what you want. The main hook points are pre-install, post-install, pre-upgrade, post-upgrade, pre-delete and post-delete. There are also a job with Helm. Two practical notes. Hook resources are not managed like normal resources. Helm creates them and, unless you tell it otherwise, leaves them lying around. So set a hook-delete- policy or you will accumulate hundreds of completed migration jobs. And ordering between multiple hooks at the same point is controlled by a hook-wait annotation. Lowest first. Hooks are powerful and they are also where charts get hard to reason about, so use them for genuine lifecycle needs and not as a general-purpose scripting mechanism. Concept 8. Debugging, and the one command that will save you the most time. Here is the single most useful thing in this entire episode. When a chart misbehaves, do not deploy it and squint at the cluster. Render it locally and read the YAML. Helm template with your values prints exactly what would be sent to Kubernetes. No cluster needed, nothing installed, nothing broken. 90% of chart bugs are visible instantly in that output. The value you thought you set is empty, the indentation collapsed, the if block excluded the whole block. 3 companions. Helm template with --debug shows you more when the render itself fails. Helm checks the chart's structure and catches obvious mistakes before you even render. And Helm upgrade with --dry-run and --debug renders against the real cluster. So it also catches things that only fail server-side, like an invalid field or a rejected admission webhook. Now, the class of bug you will actually hit, and this is where Helm's design shows through. Whitespace. Because Helm templates YAML as plain text, it does not understand YAML structure at all. It is just doing string substitution. Indentation is your problem. Inject a multi-line value without the right indent helper and you produce syntactically broken YAML. That is why you constantly see nin-for and to YAML piped into nin in real charts. Those are not decoration, they are load-bearing. Concept 9. The honest criticism and the alternatives worth knowing. Be able to say this out loud, because it is what a senior engineer will want to hear. Helm's central design choice is that it templates YAML as text. It does not parse your YAML. It does not know what a deployment is. It does string substitution and hands the result to Kubernetes. That is why Whitespace breaks things, why your templates fill up with indented and the YAML, and why a complex chart becomes an unreadable super-logo template syntax wrapped around YAML that you cannot read without rendering it first. It is widely criticized, and the criticism is fair. So, what do people use instead? Kustomize takes the opposite approach. It does not template at all. You write plain, valid YAML, and then you write overlays that patch it structurally for each environment. It is built into Kubectl. It is far simpler, and your base YAML stays readable and lintable. What it lacks is packaging and versioning and dependencies, which is precisely what Helm is good at. And then Argo CD or Flux, GitOps tools which are not really alternatives at all, but a layer above. They take a chart or a customized overlay from Git and continuously reconcile it into the cluster. In practice, the mature answer, and the one that will land well in an interview, is Helm for packaging and distributing software, especially other people's software, customized for environment-specific tweaks to your own manifests, and Argo to actually apply either of them from Git. They are not competitors. They solve adjacent problems, and knowing which is the point. Let us put it back together. A chart is a folder, metadata, a values file that is your public API, templates with holes in them, and dependencies. Values come from a precedence chain, defaults, then your per environment file, then -- set at the top. A chart is a class and a release is an object, and Helm stores that release in a secret inside the cluster, which is why Helm 3 needs no tiller. Every upgrade writes a new revision, which is what makes Helm Rollback a one-command escape from a bad deploy at 3 in the morning. And always use --atomic and --wait so a failure never leaves you half applied. Put shared names and labels in _helpers.tpl. Declare dependencies to pull in whole subsystems, but pin their versions, and do not let your production database live inside your application's release. Use hooks for real life cycle needs like migrations, and set a delete policy. When something breaks, run Helm template and read the YAML. Most bugs are visible immediately. And know the honest criticism. Helm templates text, not structure, which is why Whitespace hurts and why Kustomize and Argo exist alongside it rather than beneath it. Subscribe. We are working through the whole backend interview surface, one concept at a time.